Good afternoon, everyone. Welcome to today's free webinar brought to you by Macmillan and Trilpant. My name is Gyan Krishna. I'm the head of TVET Sales and Marketing. This webinar has been designed to take you through all the changes in the curriculum. If you have not yet seen a promo copy of our textbook, please click on the link in the chat. In addition, we have a PDF showing you all the changes you need to know about as you prepare to implement the new curriculum in trimester 2. Remember, you will need to order new textbooks for your students. Our presenter today is Clifford Tobayane. He is also the author of the new N4 book. Clifford is a seasoned lecturer, and I'll let him tell you a little more about himself shortly. Please post your questions, and Clifford will tackle these at the end of the session. Enjoy the webinar. Over to you, Clifford.
Thank you very much, Dave. Good day, everyone. As introduced, I am Clifford Tobayane, also the author of Industrial Electronics. I will be taking you through the changes in the curriculum for Industrial Electronics N4. But about myself, I'm a qualified electrical engineer. I'm also qualified in the facilitator, assessor, and moderator with a professional qualification in education, and with some relevant experience in the field of electrical engineering. I've been a lecturer since 2015 in many electrical engineering related subjects, one of which is industrial electronics. So it gives me great honor today to be with you guys and to be talking about the changes that are to take place in this curriculum and going forth. So what I would like us to do firstly is just make sure that you by mistake don't turn your microphone on, unless perhaps now there is that session where we ask questions. You can then turn the microphone on, but for now we can mute all our microphones. You can then participate actively, and there will be a question and answer session at the end of the presentation. So what you can do is you can then jot down all the questions that you might have as we proceed, and then you will get that space for questions and answering. Here we'll be looking at the new curriculum outcomes. What is it that has been changed, added, and what is it that has been removed in the new curriculum as compared to the old one? We'll also ask the impact of these changes in this new curriculum, and also talk about what TVET First is to offer as an integration and improvement in your day-to-day lecturing. This curriculum is to be implemented from next trimester. It means that the August examination will contain questions from the new curriculum. So that means from May 2024, Industrial Electronics N4 will now be using the new syllabus, and the old one will no longer be applicable. All examinations will be from this curriculum. So what is it exactly that students must be equipped with at the end of that particular trimester, or what is it that they will be equipped with in this curriculum? The first, most important thing is for them to gain knowledge and fundamental principle of the electronic industry. As we all know that we are in the 4th industrial revolution, we are nearly towards the end of the 4th industrial revolution. That means now we'll be entering the 5th one. So in industries, we now deploy technological advancements, and industrial electronics is one of the major subjects that equips students with those technological knowledge and technological advancement, and also for them to succeed in the working space. So in this curriculum, the students must, at the end of that particular learning period, be able or also have an application knowledge of power supplies and control, design procedures of circuitry, process control and amplification. If If you look at these 4 points, they're the key, most important points when it comes to industrial electronics. It's all about power supplies, designing of electronic circuits using transistors, diodes, capacitors, and inductors, controlling those designed circuitries, and also amplifying signals that are inserted or supplied to a circuit such that we get a signal that is greater than that. Our examination for students is still standard. It's still out of 100 marks for 3 hours. You will still get, a student will still get a formula sheet provided to them, and a scientific calculator will be allowed to be used in the exam room. But as standard, no programmable calculators will be used. There won't be any referencing allowed. That means copying. And it's a closed book, so there won't be any referencing to either previous examination papers or memorandum. Basically, that is what still is standard today. The brief changes that you should expect in this curriculum, we'll just talk about just a few overview, and then we'll then go into details as we continue. Out of the 9 modules that we had in the old curriculum, we now have 6 modules. However, in the 9, there is one module which is the cathode ray oscilloscope, the 9th module. That module has entirely been removed from the new curriculum, which left us with 8 modules. In all of the 8 modules, some of these modules have been integrated and squeezed in the 6 remaining modules. In that integration, there's then new content that had been added. And there's a detailed specification of how this content must be delivered in a classroom setting. So if you can look at module 1, the network theorem, we do have the old information from the old curriculum. This includes your Kirchhoff's laws, your superposition, and your Thevenin's theorem. Those are still there, which are the key aspects of that. That, of course, it will also include the bandwidth and the Q factors, the quality factors. So they're still there, but yet there's also new contents that have been added to module 1. Module 2, there hasn't much changes being made. There's only been a small addition, which is just from the previous level, N3, to the module 2. We'll just talk about that in depth when we get to the module description. Module 3, electronic power control. In the old curriculum, module 3 was semiconductor diodes, but now is termed electronic power control. It contains new contents and also information from the old curriculum, module 7, which was termed electronic power control. But these two are now fused together in module 3. Module 4, there isn't much changes, but we'll discuss on what TVET first book offers in that module that there are no more changes in. Module 5, amplifiers. In the old curriculum, module 5 was termed transducers, and module 6 was amplifiers. But now both these modules have been merged together to form one module, and there's new contents which have been added there. We'll discuss that as well. And then the last module, which is transducers and liquid crystal displays, LCDs. Old curriculum and new information that has been added to that. We'll also look at that in depth when we get to that part. When it comes to mark allocation, the mark weighing, now here in the curriculum review, I think much fairness has been put in. This allows our students to be able to pass the exam. Remember that the pass mark for the examination is still set to 40%. So if you can look at this module 1 and module 2, if a student goes in the exam, then they have detailed information, profound information about just these 2 modules on its own. They can be able to make it out of the exam alive, because you see, network theorem has now a weighing of 20%, alternating current theory of 20%, electronic power control, power supplies, amplifiers, transducers, and LCDs. They have 15, 15, 15, 15. So the curriculum is made in such a way that it is easy for the student to pass the exam, yet having crucial knowledge to overtake the workplace industry. Now, I want us to go into details in what has been added or what's new in each and every module. This presentation, we're not going to dwell much on what is always there in the curriculum. For an example, I've mentioned that in the network theorem, we still have Kirchhoff's superposition, and we're not going to be discussing that. What I would do is I'll be presenting to you what's new, what's integrated, merged from an old module, and what is it that has been removed from that particular module. Now with module 1, having had Kirchhoff's superposition and Thevenin's, we also have 2 theorems that have been added, one of which is the Norton's theorem, which I believe that most of you are familiar with that theorem. In electrotechnics and 4, the theorem is already there. So it has also been merged to industrial electronics. Now the curriculum was also specific to what is it a student must know after completion of this subunit. 1, the student must be able to explain what Norton's theorem is. They must be able to calculate the current, voltage, and resistance using this theorem. They must also be able to draw the Norton's equivalent circuit diagram. That is all under Norton's. But with the TVET first book, we've also went the extra mile of including how to calculate also the power in each and every resistor of a circuit. This is a precautionary measure in the event where the examiner decides to include that in the final examination. Student must not be complaining that it's not part of their textbook. We also have maximum power transfer theorem using nodal analysis and Thevenin's equivalent circuit. This theorem, for most of you, I think you are familiar with it, although it was not a priority in the old curriculum, but now it has been emphasized as a priority theorem. Here as well, the curriculum specified what is it the student must know. If you can look at this theorem, if a student has a poor understanding of Thevenin's theorem, they might not be able to come out alive with the maximum power transfer theorem. So it must be ensured that in the Thevenin's theorem, justice is made such that they integrate that information into this theorem. They must be able to define this theorem, calculate current, power, resistance by making use of this theorem. That is for module 1. Module 2, like I had said, there are not much changes, but the curriculum had brought in some information from N3, more particularly on RLC circuit. If you look at the old curriculum, it will just jump straight to series and parallel RLC circuits. But now in this curriculum, you will see that RC circuits, parallel and series, will be explained differently. RL circuit, parallel and series, will also be explained with their examples. This is just to ensure that the student has some pre-knowledge of the phased out level and also be able to integrate that knowledge to N4. In our TVET first book, we also ensured, though it is not prescribed by the curriculum, however, due to experience, we've seen that student has been having some difficulties in calculator operations. We've included some calculator operation examples, more particularly in complex numbers, the J notation. Students have shown difficult challenges, more particularly to convert polar forms to rectangular forms to polar forms. So there are examples to take the student through those conversions, which makes this book very exciting. Complex numbers are one of a challenging part of our curriculum because it is also there in mathematics. So we tried that in this book, we simplify the laws of complex numbers such that a student can simply understand these laws between a polar form and a rectangular form. How to attend these calculations when the polar form and the rectangular form are combined in one equation. How to convert that. So it becomes very simpler for them. Module 3, the electronic power control. we're still gonna be having semiconductor diodes. That is your PN junction diodes. You will still be required to draw the characteristic curve of a PN junction diode, to draw the circuit symbol, the construction. You will also be required to calculate the diode current and the diode reverse resistance. So all that information from the old curriculum is still there, with the varactor diode as well, the Zener diode, and the tunnel diode. And then the new keys on the block are the Schottky diode, the GaN diode, and the avalanche diode. Here you must be able to draw the symbol, the characteristics curve, and the application. You must know them, also with their operating principle. But they are very, very simplified in this book, and they are placed in a very simple language that you can also understand. Integrated to this module, like I said, is the old module 7, or module 7 from the old curriculum, which is the silicon control rectifier, the diac, the triac, the quadrac, and so forth. But what we did is, because there's been some huge similarities between a triac and a quadrac, the TVET first book has, made sure that the differences are much more visible than the similarities. This is also a precautionary measure to assist the student to be able to answer an exam where they are asked to draw a triac, to draw a quadrac, including their characteristic curves, also their applications. So this is what is there. Module 4, power supplies, nothing much has been added. We still have our transformers, we still have our rectifiers, we still have our filters. But if you know very well, this module is one of the challenging module for industrial electronics, more particularly when we deal with the many equations for filters. In the old curriculum, you'd see that there are many equations where you'd maybe, for an example, you are required to calculate the output DC voltage for an LC filter, for an LC pi filter, for an RC pi filter. You'll realize that there's some certain similarities in these equations. But with the TVET first book, we've just outlined the differences to be more visible than the similarities, such that they are easily distinguishable from each other. And it is easy for the student to just go through. Now, understanding that because of the time constraints, we are unable to take our students to workshops so that they see how rectification is achieved. We've ensured that in the book, we at least include a picture where a simulation can be made in a classroom setting, where you can take a transformer, connect it with your diodes and a capacitor, just to showcase for the students how a simple capacitor filter is achieved in a rectification. As you can see the diagram there. So in most of these diagrams in this module and other modules, we've also integrated this real world circuitry to show you how these things will work in a real life. Module 5, the old information from module 5 is still there. Your transistors are still there. However, there is some information which were faintly highlighted from the old curriculum. The new curriculum has now detailedly stipulated what is it that a student must know and must understand after completion of this unit. So there's a detailed information and detailed drawing along with operating principle of the classes of amplification. All of them, the class A, class AB, class B, and class C for non-complementary, systemetry, complementary systemetry, classes of amplification. So if this information has been there in the previous level N3 curriculum, but in the N4, there hasn't been much discussion and details about it. It has now been integrated from that level to the N4 level with its detailing This includes the couplings. If you recall very well from N3, we have transformer coupling, we have Darlington couplings. These are also here, integrated to this level. Remember, those levels have been phased out, so some of this information have to be brought in. We also said operational amplifiers will also form part of module 5. That is your non-inventing operational amplifier, your summing, your integrator and comparator. And we've also highlighted more differences than similarities, so that a student can be able to distinguish between these operational amplifiers in the TVET first book. But part of those that have been removed, remember I said module 9, the oscilloscopes have been entirely removed from the new curriculum. The field effect transistors have also been omitted from this curriculum. This will include your junction field effect transistor, your metal oxide semiconductor transistors have all been entirely removed, and your unijunction transistor. So those do not form part of the new curriculum. They have been removed. Last but not least is the last module, module 6, the transducers and liquid crystal display. The old module 8 from the old curriculum has been integrated, fused in this module. So all that information that is there, we'll still find it here. However, what we did, instead of just talking about a theoretical transducer in the TVET first book, we've brought in real world examples of transducers. One practical example of a real world transducer would be what we use in hospitals, the sonar scanner for pregnant women. That is part of a transducer. One general example would be your microphone to amplifier to a speaker transducer. So we've brought in all those real world examples such that when you present it in a classroom setting, it is easier for students to relate to them. New kid on the block will be the liquid crystal display. In the N4 curriculum, there hasn't been any details on this part, but just an introduction to it. Details are there in the N5 curriculum because it is also revised. There will be a new curriculum also, or there is already a new curriculum in that aspect. But for N4, you would just be defining what an LCD is, listing the different, the applications of an LCD and the different types of LCD. That will just be that. However, we've also went an extra mile in the TVET first to include more details about the liquid crystal display, also as a precautionary measure in the event where an examiner decides to go an extra mile during the examination. So then it is easier to peruse through. Now, there are many changes that or rather there are many integrations, many additions, simplifications that we've made in the TVET first book. However, all of these changes and additions, they perfectly align with the curriculum. They complement the curriculum perfectly. And we are to discuss those changes, and we are to discuss what is it that the TVET first book offers you and your students. Now, the package of these books will include one, a student book that has all simplified operating principle, simplified circuitry, applications, and many more features, special features, which we also will discuss on a later stage in this webinar. We have a comprehensive lecturer's guide, and we will also discuss what is it that is included in the lecturer guide. And one of my personal favorites is the student workbook. We'll also discuss what and why this workbook is my favorite part of the package. The comprehensive lecturer guide will include the background information about industrial electronics, what is it that is entailed there, and also how to go about teaching this subject, which is the suggested teaching plan. Considering that the trimester is very small, ideally it's a 10-week course, but practically it's not so. So there are suggested, proposed teaching plan how to then be at the position to manage to finish the curriculum or the syllabus in due time. There's also some DHET approved lesson plans that you can make copies of, comprehensive answers to all activities in the student book, including the summative assessment and the starter activities, which we will also talk about on a later stage. We also have this part, the memorandum to a practice exam. This is another feature, a special feature that is amazing, that is added to the student book. Because we don't want to expose our students to exams that they may think they have not prepared for by utilizing previous exam papers, we've taken the liberty of including a practice exam question in the student book that will mimic the exact external examination. So this is to assist the student to have a knowledge of what is it that they would expect in the final examination. However, the memorandum is included in the lecture guide. One of my personal favorites is the student workbook. The student workbook will have all the activities which are there in the student book, but there will be spaces, it's like a notebook, spaces provided for them for every activity to calculate and answer these questions. One of the best parts that I like about this book is the what you should know part, where each and every activity will have a hint of the exam. What is it that the student should know about this particular unit when attempting to answer questions in the exam? But here's what I love the most about this book, this part right here. Inside the workbook, there are spaces, as I've said, provided for students to work through their answers. I just screenshotted this part where we have a question, although I did not put the question here, but in the circuit in figure 1.26 there, the question goes, student must, or rather by making use of Norton's theorem, calculate the current that flows through the 6 ohm resistor. So the workbook, what it does, it will offer a space to the student just here. And there will be also an instruction on how to utilize the space. See, use the space to sketch your circuit diagram, replace the load resistor with the ammeter. So the student knows what is it that I should do. After they have drawn the equivalent circuit diagram and replaced the load resistor with the ammeter, there will also be spaces provided with hints to go about calculating. So for every section, there are hints. There is a hint that the student must be able to calculate the total resistance, so they would know that I need to calculate the total resistance. They will not forget. I need to calculate the total current, and then I need to calculate the Norton current. So that space is given with hints for the students to be able to calculate that. There will also be a space provided for them to draw an equivalent circuit diagram again, replacing the ammeter with an ohmmeter. In the final one, there will be a prescription of that. Also, space is provided for the calculations. And then there's also a space here at the top for the Norton equivalent circuit diagram that will also assist them to then calculate the current that flows through the load resistor. This is what's amazing about this workbook. It's a guide for the students on what to calculate. So this will eradicate an event where a student has calculated and they have the belief that they've covered every aspect of that calculation, only to realize on the later stage that they've forgotten to calculate the total resistance across a certain series resistor, or perhaps they've forgotten to calculate Norton resistance. But this workbook offers them that. That is what I love about that workbook. So the special features that are included in the student book, the lecturer guide, and the workbook are as follows. We have the brief overview for each and every module. The student will have a brief overview of that module, as well as the outcomes. So it's easier for them to know what is it to expect inside that particular module. The part that I like the most in the student book is the starter activity. A lecturer may choose to utilize the starter activity for a group work. Before starting with the module, you may use the starter activity as a recognition of prior learning activity. This is where you check what students bring in the session. You'll be surprised to find that students have actually performed well in the starter activity, which in a way simplifies your work as you continue. But it also assists you to identify how much effort you should put into that module because of the level of response that you are getting. So that is the starter activity. We have comprehensive examples. With the examples, we ensure that we take as many previous examinations as possible. These are not general examples. If you can check from previous exam, you'll find these types of questions in the exam, but we've integrated them to be examples. And we've also included step-by-step guides. If you can see there, for an example, the one that is more visible is the step 2, where it is guiding the student that find the Norton current using the superpositions theorem to calculate the current applied by each voltage source. You see, it's an instruction on what to do. So in all the examples, you'll find step-by-step guides. This is what you should do next. This is what you should do next. This is what you should do next. We have activities for each and every unit in a module, because a module will contain units. So each and every unit will have an activity. The activity will be exam relevant. So when the student has the student book, in the student book on its own, it's as if you are having a study guide with previous exam papers. So in this case, we've just utilized them to be in an activity form. So practicing these activities indirectly, you will be able to know what the exam will have. And then we have the QR codes, an amazing feature in the student book. This QR code closes the gap where you as a lecturer, you are not available to explain how a certain example in a book has been outlined. So each and every example in the textbook, which perhaps let me make an example of an example for complex numbers, calculating complex circuit, where you are given a circuit and you must calculate the total impedance and the total current. It's somewhat complex. It's somehow complicated because of the steps. There will be a QR code in the final book. In the final book, there will be a QR code next to each and every example, where it will direct you to a video that is made specifically for that example. A student can scan the QR code, follow the video to answer that example. So it will be the exact example in the video. So this is one feature that is amazing. Trust me, you won't find this feature anywhere else, but with Macmillan. So you scan the QR code, it takes you straight to the worked step-by-step guide video of that particular example. So then it becomes very easy. The diagrams inside the student book are simplified for easy interpretations. Some of these diagrams we tried as hard as possible to mimic the real world components. So that when you see something in hand, it will have an exact replica of what is there in the diagram. And another special feature is the photograph of components, where instead of a student knowing how a diode looks like as a symbol, which they are not even going to find in the workplace, the book also offers them the real images of a diode, the real images of a capacitor, transformer, and so forth, so that it is easier for these students to understand and relate with these things. In my classroom, I've realized that I have been talking to students about a diode, about an inductor, about a capacitor, and because some of them don't even know these terms, but immediately when I show them what a capacitor is, and you get a reaction, oh, so this is a capacitor, I know these things. I've seen it in my cell phone charger. Oh, this is a diode, I know this. So in the book, we have included those so that it's easier for students to relate to everything that is presented in the student book. Because of languages that has been there in many books of this nature, The TVET first book has simplified the level of language in the SP. This means that for every sentence or word that is a bit complicated, we tried as much as possible to give you the meaning. That means in a note form and also in a vocabulary form, so that it is easier for you to understand. One practical example would be polarity. One may not understand in practice what does polarity means, but in the vocab way, we've tried to explain what polarity means. So in each and every unit, you will have notes and vocabulary boxes that explains what is it that appears there. At the end of each and every module, there is a summary, summarizing everything that you've learned, but most importantly, only including exam-based information in the summary, so that you, and there is a part where you would teach in class and only to find that in the summary, you realize that, man, this aspect in the summary, why didn't I see it? Then it's easier for you to then go back, and revise on that part. So the summary is focusing on what is it that you will also expect in the exam. So it's an amazing feature. We also have summative assessments. Summative assessments, it's because, remember I said earlier that activities, we list them per unit. The summative assessment will then summarize all of these activities. The summative assessment on its own mimics exam-based questions. I see this part as more assistive to us as lecturers than students. Why? Because if I have to set a test, it could be a formative test in class, a weekly test, or just an ICAS contributing test. I can simply take questions from these summative assessments in all the modules and set a test using those, because they are already exam-based questions. So this minimizes me having to download examination questions, try to put them in a way that students will understand. But in the book, you can simply just take the question as is, because it is already an exam-based question, and make it as a class test or just for brief discussion in class. At the end of the student book, there's a glossary, which includes all the notes and vocabs that you've been seeing inside the book. That will explain all terminologies. So it's like a cheat sheet in a way. It explains all the terminologies to you. So it comes in handy, and it's an amazing feature that you also must take advantage of. We also have the practice exam that is included in the student book. Like I had said, students have not yet been exposed to the examination of this current curriculum. But with the practice exam, students are indirectly exposed to the exam. That means you can also use this practice exam for your ICAS controlled assessments. It can come in handy. Support that there is the practice exam memo, which is included in the lecturer guide that will assist you in the event where you decide to use the practice exam as an ICAS assessment task. You can use the memorandum to mark that assessment task. So there are many amazing things about the TVET first book. Many amazing things. So as we come to an end, just if you recall, we've touched on all the highlighted significant changes that had been taken place in the curriculum on its own. Top it up, we've also spoke about what the improved and updated TVET first textbook, Industrial Electronics N4, offers to your students and to you as well. Now, the book is created in such a way that students can use it without the help of a lecturer. This also caters for long distance learning, good people, because we've seen that in colleges we have a thing called an exam only student or part-time students, where they have an allowance to consult from time to time with their lecturers. With this book, they can study without even the need of consultation. Long distance programs can also be ran without any hassle or struggle. That's it for me, colleagues, and thank you very much. So if there are any questions about this, please, I would like us to engage in these questions so that we can assist each other moving forward. Thank you, Jan.
Thank you, Clifford, for a fantastic presentation. Tabatso, I know your hand was up for some time, so let's start off with you. You can unmute yourself and engage with Clifford. Tabatso?
Sorry, sir. I was just trying to log in. Maybe I did a mistake.
No, that's any feedback on the presentation done by Clifford?
I'm still checking my things this side.
All right. Kaba, we move on to you. Kaba, your turn. Please go ahead.
Am I clear? Can anyone hear
Can
me?
hear you? Yes, loud and clear. Go ahead.
Okay. My question is, what was the motion behind to remove the oscilloscope section or module from the N4? Yes.
Thank you for that question. I'm not sure if we should take all of them or I should answer as the question comes.
Let's do it one at a time because you may not remember all of them, so it's fine.
Yeah.
I think you can go ahead.
Thanks. Remember, cathode ray oscilloscope are an old instrument used in testing equipment, let me put it that way, where it gives us feedback in the signals that are there in a particular circuitry. It's an old system. Like I had mentioned that we are in the 4th industrial revolution and slowly moving to the 5th. The oscilloscopes are no longer in that much use. So their industrial relevance is no longer applicable. The curriculum, the design of this curriculum is such that each and every aspect of it must have an industry relevance. So after some careful discussions with industry representative, it was noted that the oscilloscopes are no longer that much in use. They are outdated, hence they've been omitted out of the new curriculum. Thanks.
Okay, thanks, man.
Yeah, thank you very much. Matthews Palembe was having issues. I think he said his network was very poor. Can we make the recordings available? Yes, it has been recorded and you will get the recording either today or tomorrow. In addition, you wanted a copy of the book. I have checked under the chat. You will find a link to we put it up on our website. So please copy those links. It's got the link to the student book, the lecture guide and the workbook, as well as the curriculum guide we put together to show you all the changes. So please copy those links and you can have a look at that later. I saw another hand up. I'm just trying to give the next person a chance. Yeah, you can just unmute yourself if you've got any questions for Clifford. Just unmute and you could pose a question directly to him and he'll be able to assist you as best he can. Even if you just want to say something about the presentation, how did you find it? The positives, is it going to help you as you implement the curriculum changes in the classroom? Are you better placed after this? Yes, Sinatile, you can unmute yourself and share your feedback with us. Sinatile Molloy from East Cape Midlands.
Hello? The question is, how certain are we that in those two exams we will most definitely see questions coming from this new publication? How certain are we?
Thank you for that. Listen, the curriculum has been finalized and set for implementation date. The TVET first book has already been approved by the department for distribution to colleges. So because this curriculum has not been revised now and it has not been published now, I think it's in 2022 when the curriculum was then allowed to be distributed. So the preparation from the whole of 2023 was the transitioning from the old curriculum to the new one. So it being issued out in 2022 and now it's 2024, the department has already done enough preparation for that transitioning. So there's that certainty that on the next trimester we will have this curriculum implemented. It is then said like that. However, I want to believe that if there are any changes that would, Macmillan will send you emails of these changes by the department so that you know long in advance, sure before that trimester even starts. But at this point, we are seated with a 99.9% certainty that it will definitely be implemented next trimester. I'm not sure if I've satisfactorily answered you.
Yeah.
I think Anne is not here now. If there's anyone with a question, please, you can just unmute yourself and speak.
Yeah, so NG Alamini wants to know where can we find the links to the materials. It's under the chat. If you, where it says polls and chat, have you found it? I've shared all the links there. But what I'll do, I'll also put it in the question box just in case. I will include all the links when I send the recording to you, so you'll have access to all of that that appears under the chat if you're not able to see it right now. So don't worry about it. You will get it as I promised by tomorrow. Any further questions? Yeah, you just need to unmute yourself and you can speak. You don't have to wait. So Sinatila's comment, Clifford, is I am so pleased with module 2, where the conversion shown done to assist the students punching the calculator. I don't know if you want to comment on that.
Yes, no, thank you very much. There's actually more simplifications which are there. I think even in the promo copy, although some of these simplifications will then be in the final module or the final book, but even in the promo copy, those are there. There are many more simplifications, more particularly to complex numbers, which is one of a bit of a difficult or a challenging unit in industrial electronics and for even in mathematics. So there are many simplified sessions. So thank you for seeing that. It's a very good.
Can we start ordering new textbooks for N4 to N6 for next trimester? You can do that, but it'll take a bit of time, as Clifford will attest to, that the books are being changes had to be made after the submission process. So Clifford, where are we in terms of that?
I think for module 4,
Clifford,
it's
are you
ready.
still with us? I don't know if we've lost Clifford. You can
Yes,
start
I'm
placing
here.
your orders. I'll also send the ISBNs to you when I send the recording and the links to the various sites. I will include the ISBN, so you must make sure that you have the correct ISBN when ordering. Okay, I don't see any hands up. I think we've addressed all the questions thus far. And lecturers, thank you very much for your time. I know it's a busy time for you with exams and marking and everything else that goes with that. But thanks for availing yourselves. And as promised, I will send you all the information as soon as everything's ready. So be on the lookout for that. And then probably a good idea will be for you to communicate with this group, to share best practice, to share information, and just to help one another as you work through the changes. And I'm sure Clifford will be on hand to also assist you. So if you would like, I'll also include his email. So if you want to correspond with him, about anything regarding the teaching of industrial electronics, I'm sure he'd be glad to. It seems like he's dropped off. Wabonza, I don't see Clifford still on here. So I won't be able to answer your question, but what I suggest you do, you could respond to the email that I will send later, either today or tomorrow, and then you can pose your question and I can get Clifford to respond to you. Would that be fine? I'm not sure if he's had some technical issues on his side because he seems to have dropped off. Clifford, have you rejoined?
Yes, I'm here. Can you hear me?
So let's leave it at that. And yeah, you can just await further communication from my side. Thank you, everyone, once again. We look forward to your feedback and all the best, and have a good break that's coming up pretty soon. Thank you. Bye-bye, everyone.
Yeah.